In this video, I'm going to talk about some of the air treatment processes. So these are some of the processes that you can do to the air of a certain condition. So first one, let's say after you have plotted a point on the psychrometric chart, that is an air with a certain condition, which is in this case 30 degrees Celsius dry bulb and maybe around 23 degrees Celsius wet bulb. So let's say you heat up the air, you do sensible heating to the air, it will start to move. It will start to shift in a certain direction. So for heating, it will move towards the right hand side. It will move towards the right. Because as you can see, whenever a point moves to the right, the most obvious change in properties will be the dry bulb temperature. So of course the opposite, when it's moving towards the left, it is sensible cooling. How about going up and down? If a point is moving upwards, for example in this case from 0 to 3, that is a humidification process. Why is that so? Because the humidity ratio is actually increasing when it's moving upwards. In this case from 15 grams per kg to 20 grams per kg. So the opposite will be dehumidification when the humidity ratio drops, let's say from 15 grams to 10 grams per kg. So these are generally, these four directions represent the four different processes that will happen to the air. But that doesn't mean it can only move vertically or horizontally. It can move in any of the direction 360 degrees. So if it's moving from 0 to 5 in this direction, 0 to 5, it is a combination of moving to the right and moving upwards. So as you can guess, it is sensible heating plus humidification. So of course 0 to 6 is a combination of moving right and downwards. Move to the right is sensible heating and moving downwards is dehumidification. 0 to 7 will be sensible cooling and humidification, and finally 0 to 8 is cooling and dehumidification. So most of the time in air handling systems, the air will move in either 0 to 5 or 0 to 8. That means it's either moving to the right and upwards or moving down and leftwards. So in a tropical climate, for example, when the weather is very hot, the normal temperature outside is like 32-33 degrees Celsius, and usually it's also more humid in a tropical climate. So if we want to condition the air to something that is comfortable indoor, the general direction will always from 0 to 8. And as for cold countries, it will be the opposite. Most likely it will be 0 to 5. Now let's look at the different so-called side effects of heating up the air, because when you heat up the air, there are some other changes in properties. It's not only the dry bulb temperature. So when you heat up the air, of course the most obvious reaction, the air will become hotter because your dry bulb temperature increases. As it's moving in a horizontal manner, the humidity ratio, there is no change. It stays as 15 grams per kg in this case. It's not going up or down, so the humidity ratio stays constant. The air will become lighter as we can see the specific volume increases. So specific volume initially is around maybe 0.88 when you focus on the two green color line, and when it's moving to the right, it hits maybe 0.90. So as we have learned before, whenever specific volume increases, density will start to decrease. So when density starts to decrease, it's perceived as becoming lighter. So hot air rises, cold air sinks. This is the justification for it. The air gains sensible energy. So as we can see, how do we determine whether air gains or loses energy? We have to look at the enthalpy value. So in this case, the enthalpy from maybe around 67, it increases to maybe around 73. So there's an increase of enthalpy value. So that's why the air is says to have gain energy, and to be more specific is sensible energy. And lastly, the one that is not so obvious, whenever we heat up the air, relative humidity will decrease. Relative humidity decreases when you heat up the air. So the easiest way to explain this is using this illustration again. So as I mentioned before, the dry bulb temperature is as good as the container capacity, and the humidity ratio is as good as the amount of water inside the container is as good as your humidity ratio, and percentage filled is equal to RH. So as we heat up the air, the container size become bigger. So we upsize the container by having the same amount of water inside the container. Now the percentage filled actually start to drop. So that is why your relative humidity will decrease, because the capacity to hold water increases whenever you increase the dry bulb temperature. So for sensible cooling, all the effects will be opposite. So I will go through a bit quickly. So the air will become colder because dry bulb temperature decreases. Humidity ratio will stay constant as well, because it's still on the same horizontal line. The air will become heavier as we mentioned, hot air rises, cold air sink. And this is because the specific volume in the psychrometric chart actually decreases when it moves to the left. The air loses sensible energy, and in this case, because the specific enthalpy has dropped from 67 maybe all the way to around 61 in this case. The relative humidity will start to increase. If you see over here, it is from around 55%, it increases to around 80%. So using the same illustration, the container size now is smaller. You downsize the container with the same amount of water inside, the percentage filled will be higher. So that is why the RH increases. Now, how about humidification? When you start to humidify the air by maybe using a humidifier inside the room, first thing that will happen is humidity ratio will increase. Okay, because the grams per kilograms of dry air will start to increase. So in this example, from 0 to 3, it is from 15 grams per kg to 20 grams per kg. Relative humidity increases, which is quite a straightforward reaction, because using the same illustration, the container now will have more water filled in. So using the same illustration, so initially you have this amount of water. By increasing the humidity ratio, you are actually topping up water into the container. So the percentage filled now will be higher. Dry bulb temperature remains constant because it's the same vertical line. So in this case, it stays at 30 degrees Celsius all the way. The air gains latent energy. Enthalpy again increases from 67 to around 80 kilojoules per kg. So both sensible heating and humidification, the air will gain energy. Just that one is sensible energy, the other one is latent energy. And lastly, the air becomes lighter, which is something that is kind of unexpected. So over here, you notice that the specific volume increases slightly, increases by a little bit. Okay, if we look at the slanted green line scale, it actually increased by this amount. So why is that so? Okay, the reason is because H2O molecules or water vapor in the air is actually lighter than the mass of the air itself. So because H2O weigh a bit lesser, so the air actually becomes lighter when you have more moisture in the air. So dehumidification, all the effects will be opposite. Humidity ratio will start to decrease. As you can see from here, it's from 15 grams per kilograms all the way to 10 grams per kg. Relative humidity decreases, As you remove water from the container, the percentage filled now become lesser and lesser. So RH will decrease accordingly. Dry bulb temperature still remains constant because it's the same vertical line. The air loses energy, and to be more specific, is latent energy. And lastly, air becomes heavier because, as you can see from here, specific volume drops, so density will increase. So let's talk a little bit more about this dehumidification process. In practice, it's very difficult to achieve this because you will need to use some chemicals. For example, the most straightforward method is to use chemicals such as this desiccant, okay, or silica gel to absorb moisture in the air. But the problem is, after this chemical is saturated with water, it is unable to absorb any more moisture. So in order to make it capable to absorb more moisture, you have to regenerate it. So how to regenerate it? You have to heat it up such that water inside the chemical will start to evaporate. Then this process have to be repeated. So in a building context, this is almost impossible. Okay, you cannot just introduce a lot of this desiccant and do these regenerative processes again and again. It's too much of resources. So in a building context, how do we achieve dehumidification? That is by using the method of cooling. So as I mentioned just now, if we are able to cool down the dry bulb temperature to a low enough value, the container size, let's say you downsize it to a very small value, what will happen is the amount of water inside will overflow out. So condensation will happen whenever you decrease the dry bulb temperature low enough. So the lower is your dry bulb temperature, the lesser is the capacity, the ability to hold moisture. So this method is commonly employed in the building context inside the air handling unit, where we cool down the air below the dew point temperature. So in the psychrometric chart, how will it look like? So for example, if you have a 25 degrees Celsius air and 70% RH, if you start to do sensible cooling, it will start to move towards the left. So once it reaches dew point, in this case dew point temperature is 20 degrees Celsius, and if you continue to cool it down further, it will start to move down this saturation line, this 100% saturation line. Because it cannot move further to the left anymore, it has to be bounded by this saturation curve. So for example, in this case, it will go to 19 degrees Celsius, 18, 17, 16, 15 degrees Celsius will be over here. And let's say you cool it down all the way to 10 degrees Celsius. So what do you notice? As the dry bulb temperature reach 10 degrees Celsius, so does the humidity ratio. The humidity ratio will also get affected. So initially, it's around 15 grams per kg, but because you cool down the air until it is 10 degrees Celsius dry bulb, humidity ratio also drops accordingly until it's around 7.5 grams per kilograms. So by doing cooling, you are effectively dehumidifying the air at the same time. So that is what happened in a building context, and we will supply this cold air to the room and it will get heated up again. And this process happens at the air handling unit. Thank you.